All right, so let's go ahead and get started. Continue to introduce yourself in the chat as you come in. Good evening. We are so excited for tonight's peer exchange hosted by GBH Education and PBS Learning Media, our free digital resource platform for teachers. This webinar is supported by NASA as part of our Bringing the Universe to America's Classroom project. So before we dive into tonight's content, I want to acknowledge that I'm calling in from Boston, Massachusetts, where GBH is headquartered, and that these lands where we do our work from are the ancestral and unceded homelands of the Mashpee Wampanoag, Aquinnah Wampanoag, Nipmuc, and Massachusetts peoples. We acknowledge the truth of violence perpetrated in the name of this country and forced removal from this territory, and we honor and respect the many diverse Indigenous peoples still connected to this land. I'd also like to acknowledge that this has been a tough year, both in and out of the classroom, and I thank all of you for making the time to join us for this peer exchange tonight, especially to the teachers. Thank you, thank you, thank you for all that you've done for students in 2020 and continue to do in 2021. So we have an exciting program for you all tonight. We'll start with some quick framing of how we came to the work of developing the framework we're talking about today. And then Dr. Blakely Surasaki, who I will introduce in a bit, will give an introduction to the framework. And then after this intro, we'll dive into the most exciting part of tonight's webinar, which is a live workshop of 2 lessons submitted by some awesome and generous teachers on this call, conducted by Dr. Surasaki and teacher extraordinaire Mariana Atadici, from Lowell Public Schools, who I'll also introduce in a bit. And then we'll close them with some Q&A. But I also want to call out my colleague Matul, who's facilitating the chat box behind the scenes today and will be curating questions along the way, as well as popping in links and resources. Thank you, Matul. So some context. Last year, NASA charged us to come up with a framework for diversity and equity to help guide our work in the Bringing the Universe to America's Classroom project. And if you're not familiar with this project, it's an extensive collection of K-12 Earth and space science resources that's on PBS Learning Media. Before we dive into the framework, however, we should say that this isn't the first time we were thinking about diversity and equity in the science media we produce. It's been a long road of continuously increasing our own understanding, improving our resources, and providing more tools for our diverse learners. We've focused on providing technical supports for our students with disabilities, supports for English learners, including embedded vocab supports, audio functions, Spanish translations, and we're in the process of aligning resources to Universal Design for Learning principles, which supports diverse learning needs and preferences. And if you're interested in learning more about UDL, you can check out a webinar series we hosted this past fall. Matul will share the link in our shared resource doc at the end of this webinar. Now to the framework and today's webinar focus. Over the past year, we've worked with partner teachers to create a series of peer exchanges focused on how to have conversations about social justice and how to promote anti-racist teaching in the classroom. And we hosted panels of teachers from across grade levels who shared their anti-racist practices. We also hosted Goldie Muhammad in talking about her phenomenal historically responsive literacy framework. But over and over again, we kept hearing from science teachers, okay, I get the concept of culturally responsive teaching in English or in social studies, but I still don't understand how to apply these concepts in my classroom. And I think this is because when we think about culturally responsive teaching, we usually think about humanities subjects, diverse texts in an English classroom, for example, or diverse perspectives or social justice movements in a US history or civics class. And we think of science and science education as neutral, objective, and separate from the context of everyday society. Whereas in reality, as we'll talk about today, the development, study, and application of science is as subject to bias and perspective as anything else. So when NASA asked us to create this framework for diversity and equity, we wanted to think about how to promote equity beyond technical accessibility and diversity beyond the context of learning preferences. And how could we really address diversity and equity in terms of students' identities in the science classroom? We're a media organization, so we specifically are looking at diversity and equity through the lens of K-12 science educational media. And our primary goal for this framework was to make sure that we at GBH are being thoughtful about producing media. But because of all the feedback we were hearing in these webinars from science teachers, and because of the reality of how critical educational media has become during the pandemic, we also saw the benefits of translating this framework into a teacher's guide for selecting and contextualizing media for the classroom. And that's what we're going to focus on today in the bulk of our webinar. So the work of the framework has been driven by an amazing advisory group, which we selected to ensure representative expertise in science identity, culturally responsive teaching, Indigenous ways of knowing, working with English learners, pre-K-12 curriculum pedagogy, and professional development. And these advisors also represent people who have expertise that span K-12 and out-of-school time learning settings. We have Megan Bang, Carrie Zhao, Bryant Kent Wallace, Anne Roseberry, Christopher Wright, Edna Tan, Felicia Mensa, and joining us from this advisory group are two guest speakers today. The first guest speaker and teacher advisor, Mariana, who teaches English learners at the Makaloff Elementary School in Lowell. She's also in the faculty pool at Fitchburg State University, the Collaborative for Educational Services, and the Lowell Teacher Academy, where she teaches and mentors educators seeking ESL licensure. And prior to working at the Makaloff, she taught at the STEM Academy in Lowell for 7 years, where she specialized in teaching STEM to English learners of varying proficiency levels in grades K through 5. Mariana is also a longtime GBH partner and a former GBH educator ambassador. And also joining us is our fearless advisory group leader, Dr. Blakely Surasaki from the University of Washington, Bothell. She is a faculty member and senior research scientist in the School of Educational Studies and the Goodlad Institute for Educational Renewal. She has expertise in curriculum development, professional development, culturally relevant teaching, and environmental education. She also has experience teaching both formal and informal K-12 STEM education. And prior to her position at UWB, Blakely was the STEM director for a nonprofit that provided PD for K-12 teachers, university faculty, and STEM professionals. She has a PhD in teaching, curriculum, and educational policy, and a master's in science education. So without further ado, I'm going to hand it over to Blakely, who's going to introduce us to the framework using 3 examples from PBS Learning Media to illustrate. So Blakely, whenever you want me to move on a slide, just say the word.
Great, thanks, April. So if you look at this slide, this has the 3 major categories that we were interested in when we were thinking about equity and diversity. And then one big overarching category. So the big overarching category is what's in the middle circle, and that's anti-deficit perspective. So it was really important to us, and by us, I'm talking about not just the people in this panel, but also the advisory group, to really make sure that an overarching principle is an anti-deficit perspective. And this is the idea that it's not about kids and students being behind or lacking things. It's about focusing on the strengths of students and the communities that they come from. So that's a really important perspective overall for this. The first category within that we looked at was thinking about people representation. So that's really who does science, who are the people. So you've probably heard that we often talk about who the role models are for students. And that's a really important part of thinking about science and who pursue science. The second part is about representation and what is science. So how are we representing what science is? And then the third category is about access and engagement. So what opportunities are we providing youth to be able to engage in science? And we'll go into more detail of those. So do you want to switch slides? Thanks. So when you get a chance to look at that actual framework, you'll see that it's a table. And so we just split this up into the 3 categories to make it a little bit easier for you to digest. And so as you'll notice on the very top, we have the anti-deficit perspective because that's really important and informs all of the work that comes underneath it. So the first aspect of this that we'll dig into is the people representation. And so by that, we're thinking about representation of people from diverse backgrounds, people that are traditionally marginalized in science and STEM fields. And that can be due to race, ethnicity, social economic status, English learners, women, other categories like that. So it's really important to include representation, a variety of representation of the people who do science, and also to show these people that have a variety of interests and values and cultural practices. So you may be familiar with studies that have long been done about who is a scientist, where traditionally people will draw a white male who has crazy hair and is in a lab coat. And that's a very stereotypical image of who a scientist is. And that's still, although those ideas are changing, that still is a prominent image for a lot of people. And so it's something that we can address through diversifying the people representation. That also includes youth, representing youth as scientists and the variety of youth that do science and their communities and intergenerational groups of people who are doing science. Um, the final aspect of that category is really thinking about the contributions that people are making to science. So there's a lot of contributions by various communities that are often not privileged in a very Western science representation that we sometimes see in schools. Um, so this is a slide that shows Molly Denali, which is produced by PBS. And so if we think about people representation, this is a really important show in that it includes or focuses on people of Alaska and Native backgrounds, and it also includes Black youth. Um, and so you're seeing a diversity of youth that are actually doing, and the main focus of the characters that are doing the science in it. So that's a really good example of increasing diversity of representation in media. Is there anything else that you want me to mention here, April?
Yeah, I would also mention that this screenshot is on PBS Learning Media. So we take clips from the show, and you'll see that there's contextualization with informational text, there's background readings, and other teacher supports. Um,
So when we're talking about who does science, this is really important also. And obviously the who does science, the what does science look like, and access and engagement are all intertwined aspects. So here I'm going to talk a little bit about how the who does science is intertwined with what is science. So really, if we think about the people who do science, those are the people who are making decisions, which can be influenced by other aspects as well, but who are making decisions about what science is done, right? Like what questions are asked, what questions are studied. And so in this example, you see a picture of a badger and a coyote. And so one example of this is from a very Western perspective, when scientists were studying this phenomena of hunting of badgers and coyotes, what they initially saw was this competition of these two species, that they were competing with each other for their prey. Um, but what native scientists were seeing was actually a mutually beneficial relationship where they're actually working together to hunt prey and supporting each other in hunting their prey. And so as this was studied a little bit more, it turned out that they actually do have a mutually beneficial relationship and they can work together to hunt their prey. And so that's just an example of how it's important to have various perspectives, because we definitely bring our perspectives into our observations that we're making and our interpretations of data. And so it's really important to be able to have those variety of backgrounds, because we do have those different perspectives, and it does influence not only the questions that we ask, but then how we investigate and interpret those questions or data for those questions. So that leads us into this idea about what is science. And so traditionally in our schools, um, it's founded on a very Western and kind of white middle, upper middle class perspective of what science is. Um, and so this is really the idea about expanding our understanding of what science is, that we do have biases that play into science. So a lot of times science is taught as very factual, and it's very black and white, and there are yes or no answers or whatnot. And we know that's not true, actually. So as we talked about, the types of questions that are asked, the phenomena that are investigated, those all depend on who's asking the question. This is pretty common I might be getting ahead of myself, but in medical fields where, you know, a lot of people ask questions and a lot of our data comes from kind of white people and oftentimes white males as well. And so there often is not as much research from other populations. Um, a lot of times we don't talk about how science evolves over time. And as we gain new tools to investigate, we get new sources of data, those theories and ideas can change over time. And sometimes students have a perception that, you know, we just have science and there's just an answer. And so it's just facts. So it's really important to for students to have representations of science and how you do science. And so the NGSS practices are a big step in that direction because it's focused on getting students to actually engage in science practices. So in that, you could talk about how are we collecting data? How are we setting up experiments? How does that impact our study when we're collecting that types of data? How are we interpreting our data? How does bias come in to our interpretations or data collection or at the various steps of experiments is really important. And then the final part of this is the relationship between science and society. So understanding the interaction between the science that we do and its impact on science and vice versa. And that relationship and that it's really important to think about that and how the science we do and how it can be either beneficial or harmful or potentially neutral. But it's really important to consider those consequences.
And before I move on to the next slide, can you talk a little bit more about this piece of the relationship between science and society and how it can be maybe harmful to communities? If you have an example in mind, like either the process of the science or the impact of like what was made.
Um, so did we have sorry. So you may be familiar with the Tuskegee study. So it's often used when we talk about ethics in science. And so that was a study basically where they chose Black males to test syphilis on. I mean, this is the abbreviated version, but it's pretty unethical to do studies without people, especially humans, consent. So it was this idea about doing it on a particular population that had very negative consequences. Um, and I'm trying to think of the other one that we mentioned in our full report. Um, I mean, another common one is Henrietta Lacks, who, you know, didn't get the type of medical treatment. They used her cells that are now used for a lot of studies. And that again was a case of pretty unethical. She wasn't informed. There was no informed consent for being able to take her cells and use them and study and things like that. So also if you think about issues like, you know, like the Flint water crisis, like why is this happening in certain areas and what's the impact on those communities and how is it being dealt with? And that's definitely an equity issue and an ethics issue.
Thank you. Great.
Oh, sorry. I was looking at you, April.
Another PBS learning media example.
Um, Yeah, so when we think about science representation, these are examples of a couple of videos that are on the GBH website. I think they're Nova videos. Is that correct, April? I don't want to misstate that. And so the interesting thing about these resources is they're videos that actually talk about how culture has influenced science. And so it talks about the Babylonian culture and why they were interested in eclipse cycles and why they studied them and how it was an important part of their culture. And so oftentimes when we teach science, we don't necessarily teach it about how it's connected to society or how it's connected to our cultures. And so this is an interesting example of showing that it is. And this also drove why they were studying, where they were studying eclipses. So just that connection is really interesting. It also shows kind of how it's changed over time as they were able to collect different types of data. And as we gained different tools that allowed us to collect different types of data and gather different types of information that then informed our understanding of eclipses.
Great. And then the last section, which is very, very meaty. Yep.
Yeah, so this last section is about access and engagement. And so you probably talk a lot about this with your colleagues about how can we provide access and engagement to youth or students. So, you know, we know that it's really important to make science relevant to students. They need to have something that connects to them. It's that question that students always ask about, so what? Like, why do we need to learn this? Why is this important? Why would I ever need to use this or understand this? And so part of how we can answer that question is talking or contextualizing the science that they're learning within students' lives. And so really being able to show examples of how they would need to use, like when it affects their lives, when they might need to use that information and that type of thing. It's really important to, and this comes into this idea about the anti-deficit perspective about building from students and communities' experiences. So finding out what experiences students have with different phenomena, you know, have they ever experienced eclipses? Have they ever experienced things related to eclipses, or whatever the concept or phenomena might be. And then drawing on those experiences and building on them so that students have something to connect to. And so they also realize that they do have really valid experiences that you can build on in the classroom. So that's really important. It's also really important to show, oh, sorry. Oh, no, you're good. Sorry. How there are multiple examples of how phenomena can occur in different contexts. So they get that sense of how it may be similar or different in different areas. So for example, if you're doing temperature or weather data or precipitation data or things like that, it may look different in different areas. And so to provide them access to those or opportunities to explore what it looks like in different areas. So we can get into that actually in the next slide. So this is an example of one of the BUAC resources that's about 30 sunsets, summer to winter. This is a time-lapse video that shows, actually in my neck of the woods, sorry, I should say that I am in Seattle, Washington, and I live in a place where in the winter we have less daylight, and in the summer we get more daylight. And so this is a time-lapse video that shows the sunrise and sunset and how that changes throughout the course of the year. So the really great thing about this video is that, you know, it doesn't require you to spend every day of your school year kind of going out and collecting the sunrise and sunset data or asking your students to do that or taking pictures and things like that, which is also great if you want to do that and can do that. But this is a way to, like, in one class period, be able to show how that changes over the course of the year. But one thing about this is this example is from the Pacific Northwest. And that might be a very different experience than what your students experience in other parts of the country or other parts of the world. So it's really important to make that connection and contextualize it in terms of your own communities. So wherever you live, and be able to make that connection and say, okay, what does this phenomenon look like in my own, in where I live? So that students can think about that, be like, oh yeah, you know, we don't, you know, we might see like a huge difference between sunrise and sunset, or we might not. So they can start to make those connections and then start to wonder about why that's different, or, you know, and why does that matter? Like, does it make a difference if the sunrise and sunset is different? How does it impact their lives? How does it impact their communities and so forth? Another access and engagement aspect, which I'm sure Mariana will talk more about as we go through this, is this idea about offering opportunities in other languages. Some of the BUAC resources also have translations for Spanish. Some of the videos have transcriptions in Spanish, and some of them will offer closed captioning in other languages as well. The other nice thing about these videos is you can slow down the time on them. which I actually did when I watched it, because as I was watching it in real time, I was trying to figure out what I was looking for, and I actually had to slow it down so I could see the times and the date stamps, so I could think through what the pattern was that I was looking at. So that's a nice aspect of this, is being able to speed it up or slow it down, and to be able to stop it at various points to be able to talk to people about it. Um, so, you know, there's a media resource itself, but then there's also obviously the context that goes around how you use these resources. So again, just really thinking about how can you, even if it's a media resource that's not of their local community, but you know, how can I contextualize it so that students can connect with it from my community? So thinking about having students think about the sunrise and sunset um, in their own communities for this particular resource.
Thank you. And just going back to that idea of Spanish translations and transcriptions, can you talk a little bit about science language before we move on?
Sure. Yeah. So oftentimes people want to pre-teach vocabulary, particularly in science. So there's all these words that may be familiar or unfamiliar to people. And so the tendency is to want to be like, okay, let's define all these words so that you'll understand them as we learn about this phenomenon, or as we go through that. We actually know that that's not an effective way to teach students, because they have nothing to connect that to. And so it's actually really important to be able to introduce phenomena using everyday language, and without all those extra vocabulary words, so that they have those experiences first. And then you introduce the science vocabulary or the academic language, so that then they can have something to connect their experiences to, and their explorations to, um, and then to give them practice using that language. So that's kind of the way to do it, so that they have a way to connect to things. We know that they learn better that way, rather than trying to front load the academic language or the vocabulary.
Thank you. And so I think that keys us up really nicely for our workshop. So in this next last portion of the webinar, before questions, we're going to be workshopping 2 lesson plans that teachers submitted ahead of the workshop. And in the interest of time, we've summarized the lessons and tried to represent the lesson plans in a way that's accessible on the screen and applicable to all science teachers on the call, regardless of what content or grade level you teach. So generally, we've pulled out the learning objectives, the general flow of the lesson, any media that were incorporated into the lesson that we have access to. There are some Google Forms that we can't, for privacy issues, access, and any other key pieces of information we thought were relevant to diversity and equity. And these summaries are not comprehensive, and both lessons were much more detailed and meaty than what's going to be represented on the screen. I also want to thank the 2 teachers whose lessons we're workshopping today, and to everybody who submitted. It's clear that you put a lot of work and expertise into planning your students' learning experiences, and we're excited to both learn from what you're already doing and also appreciate the opportunity to learn together about how to make lessons more culturally responsive. So the first lesson that we're going to look at is middle school photosynthesis and cellular respiration lesson. Takes me a while to say cellular. On the left, you'll see the teacher has identified the student objectives, and then you'll see the general flow of the lesson is they start with a do now. There's 2 activities in the do now, a Google form, which is capturing knowledge from a previous lesson, I think. And then they use a Kahoot. And so if you're not familiar with Kahoot, I am going to show it to you. It is basically a platform where you can make your own games, quizzes, or you can tap into games or quizzes that other people have created. And so this teacher has created a 10-question quiz, and you'll see a couple of them. What is used to obtain light energy? And then you click. This already has the answers filled in because it's a pre-filled link, but the student wouldn't have that. So that is their do now. And then they have their opening of the class is they review the 2 tasks together. Then there's the launch or introduction to new material where the teacher introduces the concepts around photosynthesis and cellular respiration. It seems like they do it through 2 videos. So there are 2 videos that are by the same producer. They're both on PBS Learning Media. And they're similar in style and duration. So I'm just going to show you the first one because it's only a minute long. And the other one, the cellular respiration, is similar in like style and nature. So you get the gist. But just so you can see what this teacher was looking at, I'll play it. And just to go back to what Blakely said about slowing down, if you ever use a video on PBS Learning Media, you can go to this cursor right here, and then you can do like a quarter of the speed, half of the speed, and you can change the speed as fits your needs. Right. So I'll play this 1 minute and 13-second video.
Photosynthesis. Trees, plants, algae, and phytoplankton all do it. And yes, it's a crazy complicated process, but we should probably give it our consideration because it's basically the process that powers most of the living world. If you boil it down, photosynthesis starts with a simple recipe. Take a little carbon dioxide from the atmosphere, add some water and sunlight, throw in some essential nutrients, and within a plant cell, this little kitchen, known as the chloroplast, can cook up some serious sugar, or in other words, food. It uses this food to grow and reproduce and basically live, and what it doesn't use up, it stores for later. And let's not forget that during this whole process, oxygen is produced as a byproduct. And why should we care? Well, oxygen is nice to breathe clearly, but take a step back and consider that the plant isn't just making food for itself. The sugars it produces are not only used by the plant, but also whatever eats the plant, and then whatever eats the eater, and up and then back down the food chain until you get, well, dirt. So when you think about it, whether you eat plants or not, that little green guy is using the sun to feed the world.
All right, so that's the video. And then there's another one on cellular respiration that is used to introduce some of the material. And they watch the video twice, and then the teacher asks the students to use Mentimeter to record their understanding of key vocabulary terms as they watch these videos. And you'll see that they pulled out some vocabulary, a lot of vocabulary that was in this lesson here. So going to turn it to Mariana and Blakely now. So one of the key pillars of the framework is, as you said, is to make sure that we include the people behind who do and who are impacted by science. I think this is really hard, and I think this is something we leave out a lot. So when you're looking at this lesson, how would you bring people, especially diverse people, into the classroom? And how would you do it, maybe using media or not?
Hi, everyone. So as Blakely mentioned before, like it's important to start off by, activating students' prior knowledge, kind of starting to contextualize the lesson, probably ask where and how people in that community interact with plants, how they see that happening in that community, what kind of expertise they may need to have to do their jobs. You can bring in like local farmers, landscapers, gardeners, florists, right? Anyone in the community that they see in the day-to-day lives that works with plants, and then maybe even invite somebody in for on Skype for a talk or an interview with the class. Um, Show people interacting with plants around the world in countries where maybe your immigrant students are from, to get different perspectives and compare and contrast. I think that would be a good start. And then maybe even posing a problem, showing somebody launching with a video that shows a problem that some of these community members might come across while doing their jobs, where they'd have to have some knowledge of the scientific phenomena that's being introduced. And that could even lead to um, a thought-provoking essential question or investigation questions for the lesson. I think that would be a good start. Blakely, do you have anything to add?
And before I turn to Blakely, I think Mariana, you put some links in, which will be in the resource, of some videos that you might start the video with, talking about Indigenous communities who are and their approach towards agriculture as a hook that you might start with for framing.
Yes, I think it's an opportunity to bring Indigenous peoples to the forefront and also kind of show how they learn about plants, um, the storytelling behind it, because, as Blakely mentioned before, we're used to seeing science done in a very factual way. And then I've seen Indigenous people do a lot of storytelling around the science and the plants too. That interesting connection to make.
Blakely?
Um, what Mariana said just made me think about the work that Megan Meng does, and just that their Indigenous perspectives on how they interact with ecosystems is different from Western perspectives of how we often teach about our interactions. So oftentimes people from Western perspective see themselves as outside of natural ecosystems. And so there's just a very different relationship with ecosystems in different communities. And so I think what Mariana is talking about is really important, and the perspective that people have and how they care for the land and what it means to them can be very different in different communities. And so to bring those aspects into the classroom can be really powerful.
Yeah, and I think you guys are already getting into, and I think you spoke to this earlier, like when you were talking about how closely people representation and science representation are connected. But is there any other ways that you would think about diverse science representation in this lesson, and either how media can enhance it or contextualization of the videos they are using?
So just I think Mariana mentioned some of them, but even just thinking about youth's own experiences. And so thinking about, do they garden, or their families garden, or grow things, or, even thinking about making connections to where we get our food from. So when you go to the grocery store, or if you go to the grocery store, your family does, that food comes from somewhere. So where does it come from, and how do we have access to it? Is it from our state? Is it from a different state? Is it, all those things? And then who are the people that are involved in that whole process? So there are people all along the way that are involved. So really putting the people into the science.
Great. And then I know that teachers are always thinking about student engagement and access, as you said, Blakely. And in this lesson, this teacher is displaying some of his moves. He's identified specific vocabulary. He has multiple modes of representing the content and engaging the students, like videos, interactive quizzes, oral discussion when they review the quizzes, and then the activity sheets, which aren't shown. But part of engagement and accessibility, as you talked about, is also connecting to and privileging students' lives and offering students the opportunity to engage in their own investigations. So how might you make those connections to students' lives and offer them those opportunities?
I'll let Mariana go first.
So it's important to let students explore with, bring the realia, bring for learning about plants, bring the plants in, right? Or let the students go out and investigate. I feel like it's important to expose students to uh, different, to the content in different modalities. So letting the students explore with plants and observe them and grow them, right, would be a good way to just add another modality to his repertoire, kind of. Um, and I think that would be a way to make the content less abstract, especially for, your English learners who is not understanding what the instructions are, or is not understanding your objective when you tell them. Just bringing in tangible objects, or letting them go on a field trip to explore what it is that you're talking about would be helpful too.
Yeah, and I do want to qualify everything that we're saying a little bit, and that, this was one lesson plan, and so like obviously there are other pieces that we don't have access to, and we don't know everything that about how this is taught and whatnot. So these are just some ideas about how to perhaps support support opportunities for reaching diversity and equity in classrooms and in science teaching. I didn't say that very well, but I just wanted to qualify that a little bit. Yeah, so I think what Mariana is saying is just, this is like things like videos are one piece of the puzzle, and they can do a really great job of visually showing certain things, especially with something like photosynthesis and cellular respiration. Like we can't necessarily like see it happen per se, right? Like you can see something grow, but the things like kids understanding how it works is challenging, and so videos are a great way to try and show that. So just some of the things that we're talking about, like including people in it, are just kind of ways to get students to see that a diverse range of people do work around photosynthesis and cellular representation, or cellular respiration. And just thinking about how you can contextualize this in ways that provide access and engagement to youth, and also ways to investigate it. So about that issue about what is science, just the various ways that people study photosynthesis and cellular respiration and why, and how data is collected and for what purposes, and how does that impact communities.
Great. And then I actually want to bring in a question from the chat from David Menges. How would you increase student agency or promote student agency in a lesson like this about photosynthesis? And also knowing that, a lot of us are on Zoom right now, Zoom classrooms.
Sorry, can you say that one more time, April?
How would you increase student agency in this lesson? And I added in a Zoom, especially thinking about Zoom right now.
So I don't know if Mariana, if you want to go first, or if you want me to say something.
Yes, that's when I first saw this lesson, I was like, is this a Zoom is this a remote lesson? Because it's so difficult. It poses a real equity issue when we ask students to go get something, to participate in an activity when they don't have the materials. So although the exploration piece is so key, and then providing this opportunity to engage in the content in a kinesthetic way too, but it's difficult in a remote setting, especially when you don't know what the student situations are. So videos are the way to go. And really I often stop and think, like, what is something that people cannot live without in their homes, or going outside and just like out the window looking at the sky, or observing outside of their window, to engage more on hands-on activity, and not being just on digital. It is a challenge in remote learning, but in the classroom, I feel like it's possible to make up different stations and give students options in how they want to explore the content, and then bringing in as much realia as possible, and then providing them to explore things digitally or in writing, all modalities that they must feel comfortable with.
And I just want to say that Raymond Zapata, the amazing teacher who submitted this lesson, has given permission to identify him, and he's sharing in the chat, like, he did do experiments. This is like part of an experiment when you're actually physically in the classroom, and that the video is, they show a video of the experiment before conducting, and they have a I think I wonder thinking strategy. I do want to make time for the next lesson, so I'm just going to ask one last question, move on, which is, for Mariana, how do you choose media with accessibility for English learners in mind? And how would you think about this video, the videos in this lesson for English learners? How would you tweak them or slow them down, or would you do anything? Yeah.
I always say, like, before you choose a video for your English learner students, you should try and watch the video with the sound off. That way you know what your least proficient students are getting out of the video. It's, I think, graphs and visuals to go along with what's being said are very important. And I think the videos that are shown in this lesson, the one on photosynthesis that you showed before, did a very good job in matching what was being said to the visuals that were being given. I think that was very helpful for ELLs. But it is important that you think, if I watch the video with the sound off, are my students going to get the gist of the video? Are they going to get that message that, you know, students who are proficient in English are getting? Just always ask yourself that. And I learned with Blakely that you can slow down the video, which is an awesome feature that I found in many PBS videos. And definitely pause as you go along to revisit key concepts and vocabulary, and make sure the kids are engaging with the video in an active manner rather than passively.
Great.
Yeah.
Thank you. So I'm going to move us to our next lesson, and I will try to pull in questions as they are, and we'll do a faster round on this lesson so that we can also have some open questions. This is bad time management. I know all you teachers are like, we are much more on it for our lessons. All right, so the second lesson example is sexual and asexual reproduction. Again, we have our learning objectives on the left, and you'll notice that this teacher also pulled out a separate ELL language objective. And then the teacher starts with an essential question: how does sexual reproduction lead to larger genetic variation? And just quickly, I will show you 30 seconds of their opening video, which is on YouTube. So not a PBSLM video, that's okay. All right, so that's the hook video. It seems like it's for a hook. And then there's the introduction to new material, which could, I wasn't sure in the lesson how it worked, whether it was through a lecture or a presentation. There was some reading. And then there was an Edpuzzle. So this teacher uses Edpuzzle. And if you don't know Edpuzzle, has videos, and then it allows you to put in assessment questions in the middle. So I'll just play until the first assessment question.
Asexual reproduction. When an organism reproduces, it makes another of the same species. Some organisms reproduce sexually. Cows make more cows, and pigs make more pigs. Sexual reproduction combines genes from a mother and a father, making.
And then it will pause, and then you can respond. So I'm just going to X out in case it keeps on going. And then, then there are some worksheets or activities. And this teacher also pulled out some vocabulary. So Blakely and Mariana, what are you seeing in terms of people representation in this lesson and opportunities?
So I think for this lesson specifically, I thought of, showing images of families around the world, noticing physical characteristics of children in relation to parents. This might be an opportunity to critically discuss genetic variation and racial classifications around the world. Also identify members of the community who need to understand reproduction to perform their jobs. farmers of animals and plants, and breeders, for example. Um, I would also show videos of like real life explanations of social and sexual and asexual reproduction, where you can see people at work and in action discussing a problem or and brainstorming solutions.
Awesome. And then Blakely, I'll ask you a different question so that we can get through it. So, thinking about the importance of connecting to students' everyday lives. I think the video at the beginning, it definitely catches my attention because baby monkeys, like it's so engaging. But a lot of students aren't going to go around cloning their household pets. So how might a teacher think about really privileging student experience in this lesson if that's the real world connection that you start with?
Yeah, so sorry, I was just thinking about the cloning aspect because cloning is like a whole nother area to me. I mean, it's obviously part of this, but it threw me off a little bit with the cloning and starting it, and because the learning objectives are around sexual, focused on the differences between sexual and asexual reproduction. So really thinking about, okay, what are some examples of that students might be familiar with? So I think I'm also somewhat trying to keep track of what people are saying in the chat, but someone mentioned thinking about plants and animals. So what are some examples that they might be familiar with that you can, and someone also just wrote something about fruits and vegetables. So can you actually show them those examples? Like if you're in person in a classroom, can you bring those in? Or if you're not, can you have them on your video screen and show them, or show them pictures of those things that they might be familiar with, that then you can say, okay, what's the difference between these things? How do they reproduce? How do they grow? So that you can really ground it in experiences that they're familiar with.
And I know we haven't done this lesson justice, but I do want to open up time for questions. So questions, and before we get to questions, I just want to alert people to that there is a survey in case you need to hop off early. If Matul, could you put the survey link in the chat? And yeah, we'll open it up to questions. And thank you everybody for all of the amazing suggestions and resources that you've been posting throughout in the chat.
And can I say something, but while people are thinking or writing their questions, April? So this is something that we've talked a bit about in terms of, sorry, when I say us, I mean the folks who are involved in developing this framework. But really the idea that one lesson cannot do all of these things, or it's really hard for one lesson to be able to address all these various aspects of diversity and equity. So, some of the things that we were talking about for these particular lessons, like they're part of whole units, right? So within a whole unit, you might try and address these different aspects of diversity and equity, but you might want to focus on particular aspects in individual lessons because it's just hard to do it all in one thing. So just to put that out there.
There was a question about what is student-directed learning, or what is student agency in learning?
The way
I see is how students participate in activities while learning, right? How they are active in the learning, if I have it right.
And Robin just wrote a response as well. Student agency refers to learning through activities that are meaningful and relevant to learners, driven by their interests. Well, that is a definition, and often self-initiated.
Yeah, but it's just that idea that sometimes we talk about cookbook labs or experiments where, it's very teacher directed. Kids are told what to do to investigate something. And so the decisions are often already made for them. And so giving them agency would be allowing them to investigate questions that they're interested in, and also be able to have, if you do want them to investigate a particular question, allowing them opportunities to have some say in how that's done and along the way and what you're doing.
And also, I think we can achieve that by making sure, especially for ELLs, it's great to have students engage in problems, like expose them to problems, and so that they can engage in like a problem solving activity. I see a higher level of engagement when they can identify a problem that they want to solve. And then engaging in hands-on projects and preferably place-based learning can also allow the teacher to accurately assess the English learners' knowledge, because it's very hard to assess English learners' knowledge if you don't speak the native language. But when they are actually engaging in a project, it's possible to notice their behaviors as evidence of understanding.
And then we have a question from Nikki, who needs some literature to support her fight to not pre-teach vocabulary at her school. Do you have any resources to support pre-teaching vocabulary is not effective?
Yes, so it's part of our report. And then did that also make it into the teacher guide, April?
I think it has, yes. So it is posted online at this website in the guide. So yes, and then Mitul says it's also going to be linked into the resource document. Any other questions?
So for waiting for questions, I just wanted to reiterate something important that I learned from Mariana about particularly related to media resources and the idea of being able to watch a video without sound and seeing if it makes sense and if the visuals are representing what they're supposed to be learning or what's being talked about. Because sometimes there's a mismatch between what the visuals are showing and what they're talking about. And so that could be really confusing to people. So that's I think a really interesting way to think about it is, does it actually represent what they're talking about? And then along with that, the idea of, does it have both visuals and talk and potentially like closed captioning to have that multiple ways to be able to access the information in videos? Because in the cloning video, initially in the beginning, they have pictures, but they're not talking about it. So it might be hard for someone potentially to figure out why we're watching, what we're watching.
And I just wanted to pull out a comment that I think is really great from Hanako, who said that, I think this is in relation to the video from Asexual and Sexual Reproduction. One small suggestion would be to remove the mother and father language to be more gender inclusive and inclusive to alternative family structures. Any other questions in our remaining 2 minutes? All right, well, thank you everybody for all your time and coming. The resources will be sent out, and please make sure you take, if you have time, to take the survey at the link, and then check out the teacher guide. It's posted on our website. The hyperlink is on the screen, and Mitul also sent it in the chat. So thank you so much.